F94. Locate the center of mass x bar of the straight rod if its mass per unit length is given by the formula m is equal to m naught times 1 plus x squared over L squared. So here's our diagram. Our bar goes from x equals 0 to x equals L, and it has this mass density function, or mass per unit length. So since we're trying to find the center of mass, we want to use the center of mass formula. We could find the center of mass as a vector, but it said specifically it wanted x bar, which means the x component of the center of mass. So for that, we take the integral of x dm over the integral of dm. Now mass is given as a function here. Mass is equal to m naught times 1 plus x squared over L squared. This is a linear mass density, which means that we can break this bar up into tiny pieces along the x-axis. Each piece has a width dx, and so each piece has a mass of m naught times 1 plus x squared over L squared dx. Finally, this bar starts at x equals 0 and ends at x equals L, which means our bounds of integration are from 0 to L. So setting this up, x dm over dm, well, this is x dm all over dm. Now when doing this integral, one thing that does make it easier, both terms have this m naught constant. Constants we can divide out constants from inside the integrand, and so we get m naught here and m naught here, and those will cancel. So it turns out, given this distribution, it doesn't actually matter what the mass is, only that it follows this distribution. So this x, we can distribute it inside the parentheses, so this becomes x plus x cubed over L squared, whereas this one, there's no extra x, so this is just 1 plus x squared over L squared. We integrate that, so the indefinite integral of x is 1/2 x squared. The indefinite integral of x cubed is 1/4 x cubed. Plug in our bounds from 0 to L. Having a 0 as a lower bound does make it easier. We just kind of only look at the upper bound. So x squared over 2 becomes L squared over 2. X cubed over 4 divided by L squared becomes L to the 4th over 4 L squared. And these two terms we can combine. This is 1/2 L squared. This simplifies to 1/4 L squared. So up here in the numerator is 3/4 L squared. In the denominator, 1 dx becomes x, and x squared over L squared dx becomes 1/3 x cubed over L squared. Same bounds from 0 to L means that this goes to L plus L cubed over 3 L squared. This simplifies to L over 3. So L plus L over 3 is 4/3 L. And then finally divide these two, 3/4 L squared divided by 4/3 L. One of these L's cancels with this, and this becomes 3/4 divided by 4/3, or 9/16. So the position of the center of mass of that bar is 9/16 L, or x equals 9/16 L.